Geometry, Unit 5, Chapter 7 from the book, and we're going to look at sections 4 and 5 in this section of notes today. Tessellations with regular and non-regular polygons. So what is a tessellation? Shapes that make up a two-dimensional plane with no gaps. And they're not just random shapes either, but it's a pattern of shapes. And so you can see in these two pictures, these are both considered tessellations. So you can see it's a pattern of shapes that's filling up a two-dimensional plane. In a tessellation, the sum of the measure of the angles of the polygon surrounding a vertex is 360. So what does that mean? That's a vertex. It adds up to 360. All those angles add up to 360. All those angles add up to 360. All those angles add up to 360. And so we can keep going around. All the angles on a vertex of the polygon surrounding vertex is 360. A regular tessellation uses only one type of regular polygon. And we can determine what regular polygons will do a regular tessellation if a regular polygon has an interior angle that has a factor of 360. Then that polygon will tessellate. Well, we know a square's got, those are all right angles, so it's 90. Is it a factor of 360? Well, 360 divided by 90 comes out to an even number 4. So yes, it is. A hexagon here, the angles of a hexagon are, on a regular hexagon, are 120. So 360 divided by 120, that is 3. So it comes out to a nice even number. So yes, both of those shapes will create regular tessellations. Now, how can we figure out those interior angles? Well, let's take a pentagon for example. Pentagon has 5 sides. To figure out the exterior angle, we just take 360, divide by the number of sides. So we divide by 5, and we get 72. We know these add up to 180, so the interior angle is 108. And we also know all 5 angles of a regular pentagon add up to 540. And guess what? 540 divided by 5 also gives us 108. Now, does a regular pentagon create a regular tessellation? Well, what's 360 divided by 108? Oh, that does not come out evenly. That's 3 point something. Doesn't come out to a nice number, so it does not create a regular tessellation. Only 3 regular polygons can create tessellations by themselves. A triangle, a square, and hexagon. No other regular polygon can create a regular tessellation purely by itself. A uniform tessellation is one that the arrangement of shapes such that the angles of each vertex is the same. So look at every single vertex. See, on this tessellation, every single vertex is created by an octagon, 2 octagons, and 1 square. Here, it's created by 1 small square, 1 large square, and then 2 parallelograms. Small square, large square, 2 parallelograms. Small square, large square, 2 parallelograms. So that's a uniform tessellation. It's the arrangement of shapes such that the angles at each vertex is the same. Not uniform is when that's not the case. So in other words, look here. This vertex is created by the intersection of 3 angles. But then look, this vertex is the intersection of 6 of the shapes. So it's not uniform. A semi-regular tessellation is a uniform tessellation that contains 2 or more regular polygons. So remember, a regular tessellation was only 1 regular polygon. Semi-regular is where it contains 2 or more regular polygons. So look, square, 2 octagons, square, 2 octagons. And these are all regular polygons. So regular is when one shape, and that one shape is a regular polygon. Semi-regular is 2 or more shapes, and those shapes are also regular polygons. Uniform is when every vertex is the same. Now, let's create some non-regular tessellations. And we can do this pretty easily using some regular polygons as a starting platform. So I'm going to take this square and I'm going to make myself a nice non-regular tessellation. So what I'm going to do is I'm just going to make something up at the top here. I'm going to take that, I'm going to copy it, and then I'm going to paste it down the bottom. Now I'm going to make something else. Let's make that. And I'm going to copy that onto the other side. I'm going to get rid of my square. Now I'm going to copy this. And look. See how it fits in? Fits in. And I've created a tessellation. And I could keep doing that. I could fill this whole screen with that single shape. I can do that with any regular, sorry. I can do that, yeah, with any regular polygon that can create a regular tessellation. So in other words, triangles, squares, and hexagons. So let's do the same thing. Let's create one here. So I'm going to do the same process. I'm going to copy that, paste in the bottom one. And then the last side. Take away. And there we go. This shape looks really odd, but it will tessellate. And it links in like that. And you can see it doesn't tessellate in the same way that the square did. The square had 4 sides. Well, hexagon has 6 sides, so it tessellates. You can see I can fill in all 6 sides. So it creates a slightly different tessellation than the square did. And it should make perfect sense. You can see there is our tessellation we formed. I can fill this whole screen with that tessellation. And that is the end of this lesson.